Okay, we're on page 200 down here at the bottom. Looking on page 200, at the bottom section, it says, expressed as a decimal, what part of Mr. Smith's garden contains bell peppers? Okay, here's the different vegetables that he grows and the part of the garden that it is. So looking at the bell pepper part, what do we know about bell peppers?
It's
10% of the garden. Okay, do we know how to convert between percents and decimals? Right, Dr. Pepper. So going from a percent to a decimal would be going back 2 spaces. So 10%. Move your decimal back. What's it going to be? 0.1 or 0.10. What percent of Mr. Smith's garden does not contain okra? Okay, there's 2 ways you can do this. You can either figure out everything that does. Okay, you can turn all of these into percents and then add them up. Thank you, Carson. Or you can figure out just the okra and then subtract it from the whole. Okay, I would probably say that it's going to be easier to just do the okra. So figure out what percent contains okra. What do we know about the okra?
You have to divide 7 20.
Right, it's 7/20ths, so we can divide that and get a decimal, correct?
Teachers, pardon the interruption. At this time, we need all students that are participating in the editorial writing to come to the library. And that was all students that are participating in today's UIL editorial writing come to the library.
So go ahead and turn this into a decimal on your paper. Okay, so when I turn it into a decimal, we should be getting what?
0.35.
0.35. And then can I turn that into a percent?
Yes.
Right, by moving over how many?
Twice.
So it makes the percent what?
35%.
And does it want to know the percent that does contain okra?
No. It doesn't.
No, it wants to know the percent that does not. So what can we subtract this 35% from? 100, right? Because the total would be 100%, wouldn't it? So to get the part that does not, we're going to subtract from 100. So 100 minus 35. And we should get 65%. Now I need to know which 2 vegetables cover the same area. So what it's asking is, what of these 2 are the same amount? So there's a lot of ways we can do this. We can turn them all into decimals. We can turn them all into fractions. We can turn them all into percents. What's probably the easiest? Turn them all to what? Either percents or decimals. Okay. I usually say turn everything to decimals because it's the easiest one to compare. So we already know the okra decimal. What's the potato decimal going to be? 0.15. Okay, and then we already know the 0.2, and we already know 10% is 0.1 because we already found that out. So then let's turn this 1/5 into a decimal. Is 5 going to 1? No, so you add a 0, then add a decimal, and add another 0. And it goes into 10 how many times? Twice. So my decimal is 0.2. Okay, so looking at the decimals, which 2 have the same amount? Squash and tomato. Very good. And then number 4 says, which vegetable covers an area of 18 square feet? Which vegetable covers an area of 18 square feet? How do we figure that out? What do we know about the square feet? Does it tell us anything about the square feet?
Yes, it's 120 square.
So I need 18 square feet out of a total of what?
120.
Can I make that a fraction or something?
Yes.
If I figure out, okay, right, the 18, what 18 is out of 120, then I can compare it to this. Does that make sense? 18 square feet is the part I need. 120 is the total. So when we're setting up fractions, we're always going to do the part on top of the whole, yes? So what's my part here? 18. What's my whole? 120. Turn that into a decimal. You could even simplify it first if you wanted to make the dividing easier. But if I can get that into a decimal, then I should get something that matches over here. And I actually am going to simplify this before I divide it because I don't know my 120 times, right? They're both divisible by what? 2, because they're even numbers. That leaves me with, what, 9 over 60? And those are both divisible by 3. And I get 3 over 20. I'm a little more comfortable dividing 3 over 20 than I am 18 over 120. But it would have worked the exact same way, okay? So I'm going to do my top in, bottom out. Don't think you have to simplify in order for this to work, because that's not true. And I'm getting 0.15. Which vegetable is that going to be equivalent to?
Potato.
The potato. Now, another way to work this is to take the decimal from each of these, multiply it times that 120, and see what gives you 18. But then you have to check every single one of them. Okay, feeling pretty good so far? Just kind of easing you into it. Okay, we're going to go to page 201. Okay, what these are is these are fractions, decimals, and percents. We're doing them like with real world problems now. Okie dokie. Number 1. Using a bag of fruit snacks, Summer records the information shown in the table. What color fruit snack shows an incorrect calculation? Okay, what do we got going on here in the table?
It shows the color.
Yellow.
Calculation.
Okay, it shows the count, so the number of red, the number of yellow, the number of orange, the number of green. Then she did some fractions, excuse me, fractions, decimals, and percents over here on the right. Okay, we need to figure out which of those is incorrect. Well, there's a couple ways we can look at this. Okay, we can look at each individual one. We can turn them all to decimals. We can turn them all to fractions. I'm just going to kind of go through here and look at what they gave me. So 1/4. Do I already know what 1/4 is? Right, because it makes us think of a quarter. So we know the decimal of 1/4 is what? 0.25. So we know the percentage is what? 25%. So I'm saying red checks out. What are y'all saying? Okay, yellow. 3/16. I have no idea what 3/16 is off the top of my head. Do you?
No.
Okay. They're saying it's 18.75 over 100. What do we know that's out of 100? Decimals or percents? Percents. A whole percentage is 100, right? A decimal would be out of one whole, right? But a whole percentage is 100%. So if they're saying that's over 100, they're saying that's like 18.75%, right? So if they're saying this is 18.75%, then what should it be when I work my decimal? 0.1875, right? So we could start working this. 3/16. Does 16 go into 3? No, but it goes into 30 twice. Whoops, I'm sorry, once. Just checking. Just see if you were paying attention, you know? Okay, and we can keep going, and this should give us 0.1875. Okay, now, I want you to look at the answer choices for just a minute. Okay, one says, or I'm sorry, A says red because 4 over 16 equals 0.25.
But in the chart, it's mine.
In the chart, it's 1/4, but 4 gummies out of how many total gummies? 4, 5, 6, 7, 8, 9, and 9 plus 7 is? So my total is 16. So do you see where they got 4 out of 16 from? 4 red fruit snacks out of a total of 16. Okay. B says yellow because 3 over 16, was that right? 3 out of 16 is 18.75%. Didn't we say what they said here is the same thing as 18.75%? Okay, so that's out. C says orange because 2 over 16 equals 12.5%. Well, wasn't there 2 out of 16? And equals 12.5%. They found a decimal over here. So let's look and see if that equals 12.5%. What happens when we move this decimal over twice? What does it equal? 1.25%. Well, that's not the same as what the answer choice says, is it? So that's probably the right answer. And green says green because 7 over 16 equals 0.4375. So does 0.4375, is that equal to 43.75% when we move this decimal over? What do we get? 0.4375. So what's our answer there? Orange. Okay. The reason I skipped and had you guys look at the answer choices is I want you to see that you don't always have to work out every single step. Okay. You can kind of cheat these questions some. Number 2 says, if Summer eats a red fruit snack and then recalculates the information, will the percentage of yellow fruit snacks change?
No, she ate a red one.
Okay, but what 2 numbers do you need to get the percentage? The part and the whole, right? If you take 1 gummy away or 1 fruit snack away, does it change either one of those?
No.
For the yellow?
Because it's not a part of that column with numbers.
What does it change?
It changes the whole because we took one away from the whole.
If we take 1 away from the whole, okay? So let's think about this. So there were originally 3 yellows out of 16, correct? If we take 1 red out, what is our total now? 15, right? And how many yellows do we have? Is 3 over 16 and 3 over 15 going to give us the same decimal? No. So are the percentages of the yellows going to change? Yes, they're going to change.
So F.
So we can mark out F, then we can mark out H. Okay, G says yes because the yellow now represents 2/15 of the fruit snacks. Well, what did we say it was going to represent? So we can mark that bad boy out. J says it represents 20% of the fruit snacks. Okay, by process of elimination, you would know this is probably the answer. And we can also divide it. 15 does not go into 3, but we can add a decimal and add a 0. It does go into 30. How many times? And is 0.2 the same as 20%? Yes. Number 3. Lily baked 2 dozen cookies. How many cookies are in 2 dozen cookies? 24. She gave 3/8 of them to neighbors. Twelve cookies were shared with family. Lily kept the remaining cookies. So, we know we can get rid of how many?
Well,
12, because she gave those to family, right? That leaves us with how many? So we're down to 12. She gave 3/8 of the 24 to neighbors. There's 2 ways you can do this.
Now it's 3/8 of the 12.
No,
What? How?
because she gave the 3/8 away before she shared with her family. You can either do 3/8 times 24. You can turn 3/8 into a decimal and then multiply that times 24. You can actually do 24 divided by 8 and then times 3. Okay, there's many different ways you could figure this out. If nothing else, divide the cookies up into 8 sections and then take 3 away. I would probably just do 24 times 3/8. What do I have to put 24 over? 24 times 3? $72. 1 times 8 is 8. What's 72 divided by 8? 9. So she gave 9 to her neighbors. 9 and 12 together makes what? $21. So how many cookies does she have? 3 cookies. Is 3 cookies going to be the same thing as 3%? No, she kept 3 cookies out of how many? So we can turn that into a decimal and a percent. $24 does not go into 3, but it goes into 30 one time. Which means my answer already has to be what? What's the only answer choice that starts with a 1? Minus 24, we get 6. Add a 0, bring it down. 24 goes into 60 twice. Minus 48. You get 12. Add a 0, bring it down. And it goes in 5 times. I know my writing is kind of scribbly there. Okay, 2 more. Y'all are hanging in there. Okay, Montrell uses the following coins to make exact change for his purchase. 2 quarters, 3 dimes, 1 nickel, and 4 pennies. Which statement correctly represents the coins Montreal uses to make exact change? 50% of the coins he uses are quarters. Hey, how many total coins did he have? 2 quarters and 3 dimes. That's how many coins? 5. Plus 1 is 6. Plus 4 is 10. So if he used 2 quarters out of 10 total coins, is that 50%? No. 2/3 of the coins he uses are pennies. Well, how many pennies did he use? Is 4 out of 10 the same thing as 2/3? No. 3/10 of the coins he uses are dimes. How many dimes did he use? Out of how many? Does that sound right? 1% of the coins he uses are nickels. He used 1 nickel out of how many? But is 1/10 the same thing as 1%? 1% is like saying 1 out of how many? 1 out of 100. Not 1 out of 10. So H has to be our answer. See, there are some easy ones in there. Okay, number 5 says, of the 25 students in Miss Miller's class, 3/5 made a passing grade on the homework assignment. 32/100 made a failing grade on the homework assignment. And 8% used a homework pass on the assignment. Which statement is not true about the completion of homework from students in Miss Miller's class? Okay, we know 3/5 out of 25 passed, 32/100 out of 25 failed, and then 8% did not even do it. 68% of the students did not fail the homework assignment. If 32/100 failed the homework assignment, what is that as a percent? 32%. So I'm just going to make me a little chart over here. Pass. Fail. Did not do. So for pass, we know it was 3/5. 0.32 made a failing grade. So 0.32, or we said 32%, right? 8% didn't do it. They used a homework pass on it. Sorry, I didn't realize you guys couldn't see. So if 32% failed, does that leave 68% that did not fail? If 32% failed, how many did not fail? Can't we subtract that from 100? Right, I'm getting 68. So yeah, 68% of the students did not fail. Only 3 students used the homework pass. Well, it was 8% out of how many total? So what we need to know is 8% of 25 3? Right? What's our decimal of 8%? No. Move it back twice. Once, twice. We have to add a what? 0.08. So turn it into a decimal and multiply times 25. See if that gives us the 3 students. 0.08 times 25. 8 times 5 is what? 40? And I had 2 decimals, so I'm getting 2. No, I'm not. Yes, I am. Is that what y'all got? Okay, so 2 is not 3, is it? So B should be our answer. Okay, do you see how you have to kind of take what you know about fractions, decimals, and percents and try to work it into these real world problems? Okay, I know they can be tricky. Flip over to the back. On number 1, I'm going to help you with number 1. The table shows Vivian's monthly budget for her income of $2,200. Vivian budgets $550 for which expense? $550 out of how much? Write that down. What fraction represents the part of Vivian's income she does not budget for rent and utilities? Okay, what percent is she budgeting for utilities if she's budgeting 1/4? So rent and utilities equal what percentage total? Number 2.
On page 2.
What's 30 and 25 together? So 55% is spent on rent and utilities, right? So what's 100 minus 55? So 45%. Or what is that as a decimal? Decimal 45. That's out of her total 2,200. Number 3 you ought to be fine with. Number 4. Vivian's friend, Skylar, spends 1/5 of her monthly budget on groceries. Which statement is true about the amount of money both Vivian and Skylar budget for groceries? If Vivian budgets 20% as groceries, what do we know about 1/5 and 20%? It's the same what? Percentage, or the same decimal, right? This is 0.2 and 1/5 is 0.2 also, or 20%. Okay, they're budgeting the same percentage. Do we know how much money Skylar makes? Does it give us that information? So, can we say who budgets more money? No, because 20% of $2,200 is a certain amount. 20% of $1 million is a lot more money, right? They're budgeting the same percentage. We don't know about the amount. So can we say who budgets more, or that they budget the same amount? Okay, so what's the answer going to be? J. I wanted to go through that one with you because I want you guys to understand they were asking for the amount, not the percentage. If they were asking for the percentage, right, or who uses the same part of their allotment, okay, they're using the same percentage or the same portion of their money, but we don't know how much she makes to know the amount. Connie is working to earn $200. She earns $25 mowing her grandmother's lawn and $60 for a day of house cleaning. Which decimal represents the part of money she still needs to earn? I think you guys can figure that out. Figure out what she's already earned, figure out what she needs, and then come up with a fraction, remember part over whole. Number 6, Billy's soccer team won 17 out of the 20 games they played. Sam's soccer team lost 3 games out of their 12 season. Which statement is not true about the wins and losses for both Billy's and Sam's soccer teams? And then I want you guys to try that one on your own. Okay, y'all get started on that.